All right. Good evening. This is SI Sasha. Today we're going to look at a film of soapy water on top of a plastic cutting board has a thickness of 233 nanometers. What color is most strongly reflected if it's illuminated perpendicular to the surface? Okay, here's the idea. We are in chapter 3 of OpenStax Volume 3, and now we are dealing with interference. So what have we got? We have got a plastic cutting board down here, n equals, let's just say n equals high. Then we have this film of water, n equals medium. And then air up here, n equals 1. And this is 1.33, and this is something we don't know. Point is, it won't be pertinent to our formula. What's happening here? We are shining light down. Ooh, that's not a good color. Let's say the light is green. Well, the light's not green. Whatever it is, light comes down, and it travels through here. And by the way, we're going perpendicular, illuminated perpendicular to its surface. It goes down, and then it comes back up. And what we're trying to figure out is, okay, well, the light goes in, refracts somehow, refracts back up, and goes back up. And we have to apply the correct formula to evaluate what wavelength of light is going to be reflected most strongly. So what do? Well, we take this formula, 2nt is equal to m lambda for m equals plus or minus 1, plus or minus 2, and so on. This is constructive interference for n high, or n below and in between and above. So is greater than, is greater than. The index of refraction here is greater than this one, is greater than this one. Okay, so what do we have? We have 2 times the index we're given, 1.33, times our thickness for the thin film, in which case is 233 times 10 to the minus 9 meters. And that is equal to, well, we're saying that it's illuminated perpendicular to its surface. The color that is most strongly reflected is going to be at m equals 1. Because at m equals 1, you get the brightest interference, and by extension, you can solve for what color that'll be. So you say, okay, m equals 1 times some lambda, right? All you have to do then is solve for lambda. You say 2 times 1.33 times that whole mess times 10 to the minus 9 over, well, 1 is equal to lambda. And by this, we get lambda is equal to 620 nanometers, or 6.2 times 10 to the minus 7 meters. Quite a simple one, but it's just worth paying attention to what situation you're in. There are so many specific cases of interference and m plus or minus 1, plus or minus 2, plus or minus, well, not plus or minus 0, but you're going to have m start at different numbers based off of the type of interference you're dealing with in your situation. So just make sure that you're aware, okay, we have plastic down here, and we have water up here, or soap, excuse me, and air up here. Wow, that evening is getting to me. But anyway, that's the idea. It's a rather short one, but worth paying attention to because you just have to know the situation you're in.